Hi, welcome to Proactive SaaS Security, from threats to actionable insights. I'm Tal Peleg, the Cloud Security Research Team Lead at Varonis. I'll be talking about threats in the cloud era, specifically relating to data and shared responsibility. I'll then present two vulnerabilities we found at Varonis Threat Labs and how the shared responsibility plays a role in them. I want you to leave with some more ideas on how you can test, monitor, and protect cloud environments and applications. What is shared responsibility? In an on-premises environment, we need to manage everything, replacing hardware, maintaining server uptime, keeping our runtime environment up to date, fixing bugs in software, and on top of all of that, protecting our data and compliance. The further we move into the cloud and towards SaaS applications, we offload many of these responsibilities onto the cloud provider. In IaaS, we no longer need to manage hardware and virtualization, while in SaaS applications, all we need to do is to put our data there and start working. But this doesn't come instead of data security. Cloud vendors cannot always know what data we're storing and what our compliance needs are, so they can't always protect us. From what I've seen, there is some confusion over data responsibilities in the cloud. I suggest we ask ourselves a few questions. Who manages our data? Is it us or is it the SaaS provider? How do we secure our data? So many applications out there, we need to understand what configurations we need to keep our data secure. And what is data security in the cloud? I like to say it's about controlling your data. Don't let your data control you. When there's a data leak, customers and law enforcement will come to you for answers. If you don't know where your data is and how it gets from place to place, then your data is controlling you. Data leaks usually start with misconfigurations or leaked credentials, and not due to a vulnerability in cloud applications. We can see that in recent data leaks, misconfigured buckets were targeted, public cloud storage. The service provider can only recommend configurations, verifying security controls such as MFA. They say the problem is on our side, the cloud user. Data is exposed when we accidentally make it public, data we didn't even think would be there. And moreover, if there is a leak from one cloud application, it can affect the integrity of other applications as well. So how do we control our data? I was recently at a manager's course, and we talked about circles of influence. There are things inside my control, and those I need to focus my effort on. Whether it's setting up security policies, making secure configurations, uploading and sharing data securely, or just listening to the security team at my company and pointing out any strange emails. Then, there are things outside of my control, such as new features in the applications that I use, 0 days in cloud services or third-party integrations, supply chain attacks, and when will an attacker try to access my cloud data. And for those, I need to be prepared with a good detection and response solution for active threats. We should ask ourselves what data we store in the cloud, and where is that data? Should it be there? What does protecting my data entail? Who can access it? How? And what can someone do once they have access to my data? In order to answer these questions, we need visibility into our cloud services, a good understanding of how the permission model works, and how to configure it to fit our security policy and monitor data and users across cloud applications. To protect our data, we want to know the classification of our data, wherever it is, and understand what normal and anomalous behaviors are, in order to detect unauthorized and malicious access. So to answer our questions from before, who manages our data? We do. How do we secure our data? Through principles like least privileges and zero trust. By implementing secure behaviors and managing configurations under our circle of influence, we can reduce the impact of the things that we can't control, like vulnerabilities, compromised identities, and internal threats. And what is data security in the cloud? It is a shared responsibility. We cannot rely solely on the cloud applications that we use to protect our data for us. In the end, we need to store and process our data responsibly in order to keep the internet secure and protect our own company. Now I'll present two cool SaaS vulnerabilities found by us at Varonis Threat Labs and what we can learn from them. The first example I want to present was found by Nitai Bachach, a coworker of mine and a good friend, as part of our research on securing Salesforce environments. I'll show how a vulnerability, along with a common misconfiguration, overexposed data, led to increased data exfiltration. For those of you who've never heard of Salesforce before, Salesforce is a CRM. Data is stored in records and relationships. It even comes with its own query language called SOQL, similar to SQL, and a programming language called Apex, which is similar to Java. Salesforce has a shared link feature, which allows sharing files called content documents. A content document can be a PDF, for example. And like any other record, it can be connected to other records, such as users. The shared link feature allows sharing PDFs publicly, without having to create a Salesforce account. A content distribution contains configuration of the shared link preview app. This app had an API in which we found a SOQL injection. When someone clicks on a shared link, they're presented with a small Lightning application that loads a preview of the content document. Lightning is a user interface development framework written by Salesforce on top of Aura, their app development framework. One of the first things this application does is call the getContentDistributionInfo Aura function to pull information about the shared link, such as its name, file type, and whether it is password protected. Knowing Aura, we tried enumerating which Aura endpoints we could access and saw that many were blocked. But one function we found we could call is getRecord. GetRecord lets you specify which fields you want to retrieve on any record. The shared link exposes the record ID of the content document, which we have access to retrieve. The SOQL injection in this method allowed us to change the fields that are retrieved for a Salesforce record into a subquery. For example, if we use a subquery like this, in SQL it would mean something like this. Since the API is not able to parse subquery results, if the subquery yielded any result, we would get an internal server error, and otherwise, if there weren't any results, the request would succeed with an empty list. This allowed error-based enumeration using a query like this to exfiltrate sensitive information about records relating to the file. For example, this query allows us to find the name of a linked entity connected to the shared file. Before Salesforce fixed the issue, an attacker could exfiltrate sensitive data from records, such as the document's owner. So what are the takeaways from this issue? What could you have done to protect your data? Adhere to the principle of least privileges. Limit the creation of public links if a file can be shared with specific people. Otherwise, use temporary access and review and remove unused access. Additionally, if information such as phone numbers doesn't need to be shared with your CRM, but can be stored exclusively in the directory, don't put it there and just increase its blast radius. Additionally, you should monitor anomalous access across all the cloud applications you use. Access to the undocumented Aura API would be visible in Salesforce logs as a special shared link user reading these records it doesn't normally access. The next vulnerability I want to talk about is another SQL injection in a CRM, Zendesk. Zendesk is commonly used as a wiki and help desk. It's also used to manage chat and phone agents. One of the applications provided by Zendesk is Zendesk Explorer. It gathers analytics data from Zendesk products and displays them in custom dashboards. Why did we look into Zendesk Explorer in the first place? We started by looking into Zendesk GraphQL API, because GraphQL is relatively new, and so we felt that it could hold more vulnerabilities. Additionally, we found some red flags in the Zendesk Explorer API, the main one being nested encoding. It seemed that this was an integration between two separate components where one used XMLs and the other used JSON documents. A complex API usually means more possibilities for bugs. This API we just looked at in the previous slide is the Query Template API, which defines a template for a SQL query that will be executed by Zendesk Explorer to create a report on a dashboard. When you want to create a new report, you select the dataset, then you choose which metrics to display, and Zendesk shows you a preview of the report. This is done by using the Execute Query API, which runs the query that the report would. What we found is that the dataset and metric IDs were not validated. This allowed for SQL injection in table names. Furthermore, the execute query API could be called by any Zendesk user in the account, even if that user could not create reports. I want to point out some nice tricks for any pen testers out there. One is something to look out for. Vulnerabilities usually manifest where there is an integration between two products. This does not have to be only between two cloud applications, but can also be between a main service provider and a merger that it purchased. The second thing is a trick for injections in PostgreSQL, the $$ string. Here, since single quotes were escaped, we needed to use a different way to write strings, and this syntax in PostgreSQL is usually unnoticed by security products. So how does the attack work? Since Zendesk is commonly used as a help desk, and to open a ticket, a user must sign in, self-service signup is usually enabled. The attacker just needed to utilize this setting, call the execute query API with a custom query schema, and would be able to leak sensitive data. Zendesk were super quick to fix this issue, and it really was a pleasure working with them. In less than 2 days, all the vulnerabilities we found were patched. In such a case, where you want to configure self-service registration, what can you do to protect yourself? First thing is data segregation. Store public data in a separate environment. Dashboards in your production environment probably don't need access to your development environment or to your internal ticketing system. Data segregation is not only applicable for entire service accounts, but is relevant also to classified data. Use attribute-based access controls as an additional layer of protection from exposing sensitive data with unauthorized identities. So, what have we seen today? For best practices, we talked about least privileges, using temporary access, zero trust, and data segregation. We want to especially monitor service integrations, inconsistencies in onboarding and offboarding, and data access. And we do not want to forget about SaaS applications, such as CRMs. We want to manage the configurations that we can control, such as authentication methods and sharing settings. And when testing web applications, a good place to start looking is at undocumented APIs and extra features that are not the main business of a company. But moreover, we want to look at how the service provider may have misconfigured their cloud environment. To summarize, some final comments before we finish. Don't be overwhelmed by the amount of applications and configurations you need to manage and blindly enable all of the available security configurations. Security should be easy. Security settings should help your employees and customers collaborate securely. If your security controls do not allow your employees to work, they'll find a way around them, and most likely one that you don't monitor. Finally, you don't have to do this alone. Security vendors, as well as the open source community, can help you if you include your SaaS applications in your vulnerability disclosure program. You don't want the first time you find out about sensitive data leaking from a SaaS application you use to be when an attacker is asking for a ransom to restore your data or keep it hidden. Thank you for your time. I hope you enjoyed this talk. If you have any questions or want to consult about cloud security, please contact me via email or any of my coworkers from Varonis who would be happy to help you. You can also find me on our blog, where you can read more details about the mentioned vulnerabilities and best practices and be updated on the latest news in data security.